Actually, I'm very proud that I am a 100% Malaysian product. From my kindergarten up to PhD, I all did it in Malaysia. Right? Of course, I did my primary school and secondary school all in Penang. And I came to UM, University Malaya, to study my engineering degree program, right from my bachelor to master to PhD, all in electrical engineering, all from University of Malaya. So I always joke that I'm a 100% Malaysian product. I'm very proud of it because we can still publish in international journal paper. We can still be recognized internationally. So my advice to young people is that don't think that if you do your study in Malaysia, you cannot compete worldwide. You can if you are hard in it. You can if you can commit to what you do and you have the dedication. I came from a very simple family. My father came from China at the age of 12 years old, and he was very poor at that time, and he started to become attendants in a coffee shop. And when he collected enough money, he started his own small business, and later on he became a wholesaler. So in that sense, I always believe that success does not come simple. It comes because we are hardworking. Well, I picked up engineering. Let me tell you, when I was young, my ambition is to become a teacher. I like to become a teacher. But slowly, when I was in Form 4, I met with a very good physics teacher, Mr. Leong. And he taught me physics in Form 4, Form 5, lower 6, and upper 6. And he was such a fantastic teacher that he made physics so interesting. And that is where I began to like physics. And I like mathematics, like physics. I like to become a teacher. So what should I do? So when I pick up my degree program, I put out there that I want to be an engineer because I like to apply physics to solve everyday life. But deep inside my heart, I still want to become a teacher. So what to do? I marry the two, become an engineer and a teacher. So I become an engineering teacher. I become a lecturer in the Department of Electrical Engineering. And that's how I become a professor in electrical engineering. Actually, as I said, when I did my first degree in University Malaya, I became very interested in electromagnetics. And electromagnetics, if you want to learn EM theory, you need to know mathematics, and that is where my interest is. But after studying electromagnetics, I wanted to apply it into physical world, to solve physical problems. So when I did my master, my supervising professor threw me a question. He said, okay, this is a research topic. You go and do your research topic. At that time, it was to study how electromagnetic waves interact with scatterers. Scatterers means it can be anything, you know. How electromagnetic wave interact with forests, for example, and you model forests as scatterers. And that is where I started my theoretical work. At that time, I worked with very simple IBM machine, 286. For those of us who know about 286, it's a very simple machine. No? By right, it should be modeled using, the computer facility should be supercomputer. But we don't have a supercomputer. If you want to stop there, you say, okay, I don't have supercomputer, so therefore I cannot work. That is not the way. Scientists must make full use of what we have around us. We must work within constraints. So in this case, I work on my theory using a very simple IBM machine. And I managed to solve 36-fold integral question for my scattering model. And finally, at that time, I was a master's student. We managed to publish 2 international journal papers. I was very encouraged by that. In fact, I must say something. This is a very important message, and something that I learned from my supervisor. Now, he came out with a high-order renormalization theory to explain the scattering between electromagnetic waves and random medium. As a young master student. There was one day I told him, "Hi, Professor Tan, I think that is something wrong in your model, in your mathematics." So I explained to him, I say, from your model, there was an error in the mathematics model. And it gives you negative power. As an engineer, when we measure power, it has to be positive, right? And this professor of mine did not just say, "Hey, you are just a young master student, how can you say I'm wrong?" He didn't. It took him 3 days to think over it, and one day he came to the lab earlier than me. And when I arrived at the lab, he called me to his room. He said, "Hey, Chuah, I think you are right. I may have made that small little mistake. And because of that mistake, our model can never match the experimental data. And once we correct the model, it can match the experimental data." Now, this simple story tells us that so long as you are interested in certain subject, you do your thing. It doesn't matter you are young kids or you are senior professors. You can still make it. And don't look down upon young researchers. Sometimes whatever they say may turn out to be something that is very important. And that lesson that I learned, I appreciate very much my supervising professor for not looking down upon me as a young researcher, and I learned from him. So therefore, all my graduate students, whatever they tell me, I'll never say, "No, you are wrong." I will have to think about it. And that is an important lesson to learn. Now, coming back to your question about theory and application. Now, at that time in University Malaya, we don't have a lot of research fund. So the only way we do is paper, pen, pencil, and thinking. So we do theoretical study. But after studying the theory part, we understand that, for example, in Malaysia, Malaysia is a tropical country. We are covered by clouds. So if your sensor from the sky, from the satellite, is optical, then many a time you cannot see through the clouds and you cannot detect what is on the ground. But if you use microwave is able to penetrate the clouds. And once they interact with the forest, for example, some of the energy can be reflected back to the satellite. And that is why I focus on microwave remote sensing. And why I choose microwave is because from theory. We understand that theoretically, if you use optical wave, which is also part of electromagnetic wave, the wavelength is so short that you cannot penetrate the clouds. Whereas microwave, they can penetrate the clouds. And so, by using the theoretical model, I came out with the high-order renormalization theory. I came out with the Monte Carlo scattering model. And when I spent my sabbatical in a wave scattering center in the University of Texas at Arlington, I came out with another theory, which is called DMPAC. I named the theory as DMPAC, Dense Media Phase and Amplitude Correction Theory. Because at that time, there are a lot of theories to explain the interaction between electromagnetic wave and dense media. Dense media means when the scatterers are very close to each other. For example, snow, sea ice, thick forest, right? And how do we then use our theory to explain? So I came up with this dense media theory, and this dense media theory has now been accepted by and also has been researched, continuously being researched on by researchers overseas. And they applied it into snow, into sea ice, into Antarctica sea ice. And so it is an important theory now. Now, I believe that we have to use our theory to solve practical problems. Since as an engineer, I'm also looking at solving practical problems. So we use this theory to study paddy field. For example, if you have electromagnetic wave interact with paddy, some of them will be reflected back, and from the collected microwave returns, you can explain how much moisture is on the field. And by using the moisture content, you can see the different growth pattern of paddy, and you can also predict the yield from the paddy field. So one of my master students at that time was working with Malaysian Remote Sensing Center makers, and he used this theory, study it, and we can predict the yield of paddy rice, from the paddy field. And that is one application. The other application, obviously, is to monitor the forest. When you monitor the forest, you can see illegal logging. You can see that there is some forest fire, and all this disaster management is also important for mankind. And we also have some projects in Antarctica. We use our model and also the radar set data to study multi-year sea ice. And by studying the sea ice, it is very important. If the sea ice break, if the sea ice float, you cause a lot of world problem, all right? And this is how we applied it in everyday life. Yeah. Okay, I will say this, in a university, it is not just studying the technical skill. Technically, many of our own Malaysian trained engineers and scientists, they are as good as their counterparts overseas. But what we are lacking in is some kind of soft skills. For example, as a scientist, no matter how great you are, no matter what kind of genius you are, if you do not know how to put across your idea, how to convince people about your idea, you may not get the funding. So presentation skill is something that I believe everybody needs. Right? Presentation skill, language skill. For example, when you talk to people, you must have eye contact with people. You must know when to raise your hand. And these are all very lacking in our traditional kind of teaching. So soft skills will include presentation skill, language skill, communication skill, lifelong learning. We must ensure that scientists keep studying, keep reading the new discovery so that we are abreast with the latest technology. Now, other soft skills will also include decision-making skill. A lot of us are so worried about making decisions. Decision-making skill, negotiation skill, in addition to presentation skill. Now, teamwork is also another soft skill that I believe all of us require. As a scientist, you cannot be always working in silo. You need to work as a team. So how do you interact with your fellow colleagues? How do you get them interested in your work? How do you share your experience with them? Teamwork is also an important part of soft skill. So I believe soft skill, if you want, it can be language skill, presentation skill, decision-making skill, negotiation skill, teamwork. And another important soft skill is entrepreneurship skill. A lot of scientists will just want to do their work in the labs, but it is not just doing your work in the lab. You must make sure that your discovery, your system, your software, your design can be accepted by the market. And you must have this entrepreneurial blood. And therefore, I think entrepreneurial skill is also an important soft skill. Yeah. So I always tell all my students that you can study engineering, you can study medicine, you can study chemistry, physics. But I hope that when you stay with the university, during your stay with the university over the 3-4 years, please pick up all these soft skills. So I give them some credit points. So when they collect sufficient credit points, they will graduate not only with their technical academic degree, they will also be given a soft skills certificate.
The last question by Dan.
But I wouldn't say in general about radio science. I only study a part of it, which is the microwave remote sensing. But in microwave remote sensing, I would really encourage people to look into various aspects. First, theoretically, we still need some theory because it is still incomplete. All right? Second, I would also think that in the past, when people look at microwave remote sensing, they talk about satellite, which is large satellite. But large satellite is very, very expensive. Right? So now people move into microsatellite, move into picosatellite. So I think the next important technology, as I say, I think it should be for scientists and young engineers to think about simple, light payload that can be put onto microsatellite, so that when you develop it, it's only 1 or 2 years, and you use the latest technology and you put it onto the sky and become an eye in the sky to look at all the natural resources in the world. So microsatellite, light payload onto the microsatellite, picosatellite, maybe the next emerging things that I think all of us